First is the mechanical restrictions. The FMC carrier board has the option to evaluate the functionality of its complementary RF sum board. RF sum, as seen from the figure, is placed right at the middle of the carrier board. Connectors such as RJ45s, DisplayPort, USBs, test points, switches, among all other connectors, are placed right along the edges of the carrier. The FMC card, on the other hand, is at one side of the board right across the RF sum. FMC connectors here are connected to the various I/O ports in the board as well as the PCI Express interface. With the form factor and user convenience taken into consideration, a lot of components and pin configurations here are fixed. With limited freedom to move components, the length of traces is something that must be compensated for. Ideally, we want traces as short as possible, especially for high-speed lines. The carrier is at 10.5 inches in length and 5.5 inches in height. Between the RF sum and FMC card, there are 16 gigabit per second lines that were of course prioritized. This in turn resulted to longer routes between the RF sum and the PCI Express interface, as well as the other connectors in the board. Longer traces create large current loop areas, increasing the chances for delays and noise. Some of the routing details of this design includes 60 high-speed differential transceiver pairs going up to a rate of 16 gigabits per second. That's 60 pairs of differential lines with 5 mil intra-pair matching with 5 to 30 picosecond delay. This board also has a total of 2,747 connections, which includes, as mentioned, multiple differential pairs with matching rules and in need of unbroken reference planes and power supplies that need ample amounts of copper area, all on a 62 mil board as required.